Hello students, today I am going to discuss one important model problem, that is how to find mutually perpendicular generators of a cone. Okay, we are having three mutually perpendicular. It means if you consider any two generators, those two are perpendicular to each other. Okay, here we are having three mutually perpendicular generators in cones. We have to find those generators. Okay, right. Here we are having one node point, that is the cone equation ax square plus by square plus 3z square plus 2fyz plus 2gzx plus 2hxy is equal to 0 have three mutually perpendicular generators if and only if a plus b plus c is equal to 0. It means the coefficient of x square plus coefficient of y square plus coefficient of z square. If you add these three coefficients, we have to get 0. Then we say that the given cone should have three mutually perpendicular generators. Okay, so now we are going to do a problem on this model, that is, so we have given one generator, one generator of the three mutually perpendicular generators. Now we have to find the other two generators. Okay, so before finding those two, first of all we have to check whether the given cone equation should possess three mutually perpendicular generators or not. For that, we have to check a plus b plus c is equal to 0 or not. Okay. So coming to the problem. So in the problem, it was given that x by 1 is equal to y by 2 is equal to z by 3 represents one of the three mutually perpendicular generators. Here, generator is nothing but a line equation. Okay. So of the cone, so this is the cone equation. So now we have to find the equations of the other two. It means we have to find the other two generators of the cone. So if we observe this cone equation, here we are not having x square term, y square term, and z square term. So whenever we consider the coefficients of x square, y square, and z square, we get 0. And if we add all those terms, should also we get 0. So it means this cone should possess three mutually perpendicular generators. Okay. So one was given, and now we have to find the other two generators. Okay. So coming to the solution, given cone is 5yz minus 8zx minus 3xy is equal to 0. So treat this as equation number 1. So clearly here coefficient of x square plus coefficient of y square plus coefficient of z square is equal to 0. So therefore we can conclude there are three mutually perpendicular generators. So we have to check it first, whether the given cone equation should have three mutually perpendicular generators or not, by adding the coefficients of x square plus y square plus z square, so that we get 0. So mutually perpendicular generators of equation 1. Okay. Given that one of the generator is x by 1 is equal to y by 2 is equal to z by 2. So this is one of the generator. So by using this data, now I am going to find the other two generators. Okay. So first now I am writing, consider the equation of the plane equation of the plane passing through the vertex 0 comma 0 comma 0. Since this the given generator line 2, so equation 2 is one of the generator of the given cone. So generator is nothing but the line equation. So clearly the point on this line is 0 comma 0 comma 0. So we can treat that as vertex of the cone. Okay. So now I am considering the equation of the plane passing through the vertex 0 comma 0 comma 0 and also the equation of the plane perpendicular to equation 2 is, it means I am going to write an equation of the plane perpendicular to the given line. Whenever line is perpendicular to the plane, we can consider the drs x by 1, y by 2, z by 3. In the denominator, we are having 2, 1, comma 2, comma 3. So those terms can be treated as the coefficients of x, comma y, comma z in the plane equation. So that I am writing x plus 2y plus 3z is equal to 0. So what I have written is, we have to consider the equation of the plane passing through the vertex, that is 0, 0, 0. Yes, clearly this plane equation passing through the vertex, that is origin. And also I have considered the equation of the plane perpendicular to the equation 3. So whenever you are saying that this plane is perpendicular to equation 2, we have to use the drs. Here the drs are 1, comma 2, comma 3 as the coefficients of x, comma y, comma z. So that we get a plane equation. Okay. So in this way, you have to find a plane equation every time by using the vertex and the drs. Okay, right. After finding the plane equation, now remaining generators of equation 1 are the lines formed by the lines of intersection of 1 and 3. So we have to find the two generators. So the two generators can be obtained by the intersection of 1 and 3. 1 is nothing but the given cone equation, and the plane is, just now we have find a plane equation. So whenever these two intersect, then the lines formed by the intersection of these two equations, we get the generators of our required mutually perpendicular generators. Okay, so I am writing, so let x by L is equal to y by M is equal to z by N. Treat this as 4, be the line of intersection of 1 and 3. So 1 is the cone equation and 3 is the plane equation. Whenever these two intersects, then we get a line. So I am writing that line equation as x by L is equal to y by M is equal to z by N. So this is our required mutually perpendicular line. From this we can find the other two line equations. Okay. So if equation 4 lies on 1, then so what we have to do is, here In equation 1, we are having 5yz minus 8zx minus 3xy is equal to 0. In this equation, we have to put x is equal to L, y is equal to M, and z is equal to N. So that we get 5mn minus 8nl minus 3lm is equal to 0. Okay, just I have substituted the values of x comma y comma z in equation 1. Okay, L comma M comma L. Right, we get this equation and we have to treat this as 5. And if 4 lies on 3, then we get 3 is here. We are having the third equation, that is a plane equation. Here also we have to substitute element values. We get L plus 2m plus 3n is equal to 0. This is sixth equation. Since this line is formed by the intersection of 1 and 3, so that is a common line to both of them. So that I have substituted an equation 1 and also an equation 3. So that we get two equations in the element. Now we have to solve these two equations. Okay. From equation 5, no, from 6 I am writing, this implies L is equal to minus 2m minus 3m. Okay. So now we have to substitute this L value in equation 5. So from 5, I am substituting 5mn minus 8n into minus 2m minus 3n minus 3 into minus 2m minus 3n into m is equal to 0. Okay, I have substituted the value of L in equation 5. So by simplification, we get 5mn plus 8 2s are 16mn plus 8 3s are 24m square plus 3 2s are 6m square plus 3 3s are 9mn is equal to 0. This implies first we have to write the m square term, that is 6m square. Next mn terms 21 plus 9, that is 30 mn plus 24m square is equal to 0. So we can cancel 6 from this equation so that we get m square plus 5mn plus 4n square is equal to 0. After that, we have to find the factors so that we can write m square. So 5mn can be written as 4mn plus mn, 1mn plus 4m square is equal to 0. I have find the factors. Right. This implies if we take m common from the first two terms, we get m plus 4m. And if we take m common, we get m plus 4m from the last two terms. And finally, we have to take m plus 4n common so that we get m plus n is equal to 0. So that we get two equations, that is one m plus 4n is equal to 0 and m plus n is equal to 0. So once again, we have to treat this as 7 and this as 8. Okay, right. So after getting 7 and 8, now we have to solve from 6 and 7. So here we are having the sixth equation, that is LML. We are having an equation in element, and seventh equation also we are having in element. Of course, we are not having L. Okay. So now I am going to solve the 6 and 7 equations. Once again, I am writing those equations. The sixth equation is L plus 2m plus 3n is equal to 0. And the seventh equation is 0L plus m plus 4n is equal to 0. I am solving these two equations by using the YCX method. Okay. So starting from the coefficient of m, we have to write 2, 3, 1, and once again 2 from the first equation. And from the second equation also, we have to start with the coefficient of m, that is 1, 4, 0, and 1. Here we have to write L, M, M. Okay. So that we get L by, so 2 4s are 8 minus 3 is equal to m by 3 zeros are 0 minus 4 is equal to m by 1 minus 0. So this implies finally we get L by 5 is equal to M by minus 4 is equal to N by 1. So this implies L comma M comma N is equal to 5 comma minus 4 comma 1. So this is 1 point. Okay. Also, from 6 and 8, we can get another point. So from 6, once again, we are having the sixth equation is L plus 2M plus 3N is equal to 0. And from the eighth equation, we are having once again 0L plus M plus N is equal to 0. So once again, by using the y-6 method, we can solve these two equations. So starting from the coefficient of M, we have to write 2, 3, 1, 2. From second equation, we have to write 1, 1, 0, 1. So this is L, M, N. So L by 2 ones are 2 minus 3 is equal to M by 3 zeros are 0 minus 1 is equal to N by 1 minus 0. So finally we get L by minus 1 is equal to M by minus 1 is equal to N by 1. So this implies here we get element is equal to minus 1 comma minus 1 comma 1. So therefore we get two sets of values for elements. After getting element values, so we have to substitute those element values in equation 4. That equation 4 is nothing but the required mutually perpendicular generators of the given cone equation. Okay, so that we are going to substitute element values in equation 4. Substitute L comma M comma N values in equation 4. Okay. Therefore, we get x by 5 is equal to y by minus 4 is equal to z by 1. And second one is x by minus 1 is equal to y by minus 1 is equal to z by 1. So these are the required two mutually perpendicular generators. Since one of the generator was given, so we have found the other two generators. So in this way, we can find the generators of the cone which are mutually perpendicular. Okay, once again, coming to the problem, here we have given one of the three mutually perpendicular generators of a cone. We have to find the other two generators of the cone. Okay, for that, what we have to do is first we have to check whether the given cone equation should possess three mutually perpendicular generators or not. For that, we have to find the coefficient of x square plus coefficient of y square plus coefficient of z square. So by adding those coefficients, we get 0. So whenever we get 0 by above note, we can say that the cone have three mutually perpendicular generators. So since we have given one generator, now we have to find the other two generators. Okay. So first, what I have did is I have found a plane equation which is perpendicular to the given line. Which is perpendicular to the given line. So by using the dr's of the given line, I have found the plane equation. So simply by taking the dr's 1, 2, 3 with the help of those dr's and also the vertex, the passing point of the line on the line. So by using those two, I have written a plane equation that is x plus 2y plus 3z is equal to 0. Okay. So next, after that, I have written that the remaining generators, what we are going to find are the lines formed by the intersection of equation 1 and equation 3. That is what I have written. It means whenever the cone and the plane intersect to each other, then we get the lines. Then we get the lines formed by the intersection of those two equations. So that those two lines are the mutually perpendicular generators, which are our required ones. Okay. So that I have written let x by L, y by M, z by N be the line of intersection of both 1 and 3. So whenever you are saying that this is the line of intersection of both 1 and 3, then it lies on both 1 and 3. So that I have substituted x, y, z values in equation 1 and also on equation 3. So then we get 5 and 6 equations. Okay, from 6th equation I have found the L value. So and then I have substituted this L value in equation 5, so that we get a quadratic equation in MNs. By solving those, we get two equations. After getting those two equations, I am going to I have solved 6 and 7 and 6 and 8 equations. then we get the values of elements. Two sets of element values. Why? Because we have to find two generators so that we get two sets of element values. So I'm substituting those two sets in the equation 4, we get two generators, and these are the required mutually perpendicular generators. Okay. In this way, you can find the three mutually perpendicular generators. So I have given you two problems. Coming to the second problem. So once again, one of the generator was given. We have to find the other two generators. Like as first problem, we have to do the second problem. Whereas coming to the third problem, here it was asking that find the angle between the lines of intersection of the plane and the cone. Here it was asking to find the angle between the lines of intersection of plane and the cone. It means we have to find the two lines which are formed by the intersection of the plane and the cone. That is what we have already did in the problem 1. So we have found the two line equations by the intersection of the plane and the cone. Okay. In this way, we have to find the once again the lines of intersection of the plane and cone. Okay. Further, we have to write the plane equation, cone equation, and I am supposing that one of the line equation, I mean common line found by the intersection of 1 and 2 is x by l, y by m, z by n. After that, we have to substitute x, y, z values in equation 1 as well as in equation 2. Okay. By substituting those two values, we get two equations. After getting those two equations, we have to eliminate any one of the values, either L, M, or M. Here I have eliminated M. And this M value can be substituted in equation 5. Then we get a quadratic equation, and we have to solve the quadratic equation so that we get two equations once again. Okay. So after getting these two equations, once again we have to solve equation 4 and 6 and 4 and 7. This is what we have done in problem 1. Okay, the same work to be done in problem 3. But here the question is, we have to find the angle between the lines of intersection of the planes and the cone, plane and the cone. Here we need not to find the three mutually perpendicular generators, but we have to find two generators. Why? Because we have to find the angle between the lines of intersection. We have to find the angle between the lines formed by the intersection of the plane and the cone. So that first we have to find the two lines. Okay. So after solving equation 4 and 6 and 4 and 7, we get element values, two sets of element values. So whenever we get the two sets of element values, if we substituted those two values, we get the two line equations. And in the denominator, we are having drs. We want those drs. So here I am writing that, and the drs are 2, minus 1, minus 1, and 1, 2, minus 1. Two sets of the drs after finding element values. Okay. And we know that how to find the angle between two lines when we know that the drs. And the formula for that is cos theta is equal to modulus of L1 L2 plus M1 M2 plus N1 N2 by root of L1 square plus M1 square plus N1 square into root of L2 square plus M2 square plus L2 square. So in this formula, if you substitute the values and on simplification, we get cos theta is equal to 1 by 6 and theta is equal to cos inverse 1 by 6. Okay. So, and I have given you one more problem to find the angle between the lines of intersection of the plane and the cone. So this is same as how we have finded the three mutually perpendicular generators. Okay, but the question, it was changed. It was asked that we have to find the angle. For angle, we are having the formula cos theta. After getting the few mutually perpendicular generators, we have to find the angle between those two. That is what we have to do in this particular problem, and this is very, very important in examination point of view. Okay, so don't leave this particular problem. Thank you.